Yep, so my name is Mark Pascall. I'm director of a company called 3 Months, and we're a 16-year-old company specialising in consulting and building bespoke, complex solutions using new emerging technologies. And these days our main specialisation is the blockchain and Internet of Things. I ran an Ethereum conference back in May and also co-director of Blockchain Labs. What I'm not is a IT health specialist, so get that out there straight away. But I'm going to be talking about blockchains in the context of a healthcare lens. So, the blockchain is fundamentally changing a lot of things. We're really excited. It's going to change the way software is built going forwards. It's a paradigm shift, and certainly we believe it's going to have implications for the health sector as well, as it is around the world. It's a fascinating topic, somewhat mind-bending, so I've got 14 minutes to try and explain it to some of you who don't know it. Some of you probably do get it, but I just want to cover off the basics and then talk about some of the healthcare specific use cases. So you're going to have to forgive me, but I'm going to treat you like a 5-year-old for a few minutes. So let's imagine I have an apple, and a physical apple, physical objects, and it could be another physical object, or a book, or a bit of paper saying I've had an operation, but I want to give it to you, physically hand it over to you. We don't need anybody else. I've touched it, you've touched it. We kind of don't need a third party to help in that transfer of information or value. Simple. It gets a bit more complicated if we have a digital apple, a digital representation of an apple. So let's imagine a JPEG picture of an apple that I want to give you. I might email it to you. I send you that image, but how do we know that you now own that apple, that digital apple? Maybe I took a copy of it before I sent it to you. Maybe I sent it to a bunch of my mates or after I sent it to you. So we don't kind of know who owns the apple anymore. So that's called the double spending problem, and it's been taxing a lot of very smart computer scientists for decades. How do we solve that in the digital world? A few years ago, that problem did get solved. And in order to understand how that problem was solved, we'll just try and solve it ourselves a little bit, work through the sort of thought process. So the obvious way to tackle that problem is to create a ledger, a record of all transactions. That could be a spreadsheet, a database that tracks who owns apples. Problem solved? Well, not quite. The problem is somebody needs to maintain that ledger, and somebody or some organisation. And we need to trust that person, that organisation. We need to know that they're not going to steal our apples. We need to know they're not going to tell lots of other people that we're trading apples. We also need to trust that. We also need to make sure that when we transact our apples, that we're interacting with the right ledger. And if there's multiple ledgers, multiple databases, that these databases are all talking to each other. So we need to work out who's got the authoritative source of Apple information, Apple ownership information. So the picture gets complicated and actually gets pretty messy in the digital world. So wouldn't it be great if we could have that transaction, a digital transaction, without the need of a trusted third party? Well, in fact, you can. And I guess the way that the computer scientists solved it was the concept of, the way to solve it is to give everybody a copy of the ledger. So instead of the ledger living on one computer, it's actually living on lots of computers. So on the left-hand side, we've got the traditional client-server architecture that we all know and love, and every IT system is built upon. On the right-hand side, we have a decentralized peer-to-peer system, fundamentally different system. So the database is essentially every transaction is replicated across the network, decentralized system. So if I give you a digital apple, a record of that is copied out, and I can't send you digital apples that I don't have, because then my copy of the ledger will get out of sync with everybody else's copy of the ledger. So it turns out the system is incredibly hard to beat. And the rules, the really clever math, the cryptography is all open source, it's all defined up front, and anybody can join in that network. It's open. You can become a node on that network. You just download the software and you can sort of join in, and you can actually get rewarded. They'll give you apples for donating your CPU power in running the network, and that's called mining. So this is what we call the blockchain. The blockchain is the name for that ledger, that distributed ledger concept. And I like to think of it, a colleague of mine described this really well, I thought. It's a database that's so secure it can be made public. And that's quite mind-bending. If you think about most IT systems, they spend a lot of time trying to make a database secure, put firewalls and make it very secure. The economists call it the trust protocol. It's that sort of, that's quite a good way to describe it as well. We have now found a way to digitally mimic the idea of me giving you a physical apple without the need of a trusted third party, a trusted intermediary. The other exciting thing is we can not only store on this blockchain, in this immutable record of truth, we can not only store information, records of transactions, we can also store sets of rules, program logic, business logic, set of rules, and that's what we call a smart contract. Okay, so a smart contract, it's a set of rules that gets executed, automatically executed. It's put on the ledger, we both agree to those rules, and it runs as programmed. Nobody can stop it, no third party, no government can stop the execution of that code. So pretty interesting stuff. If I can use an example, if I've got a bet, I want to make a bet with you that the All Blacks are going to win the next Rugby World Cup. We want to bet $10,000. Normal way, we'd need a trusted third party to handle that sort of money because we don't fully trust each other. You might run for the money. In the smart contract world, we could agree the rules, we could program them as code, and now those rules might say, okay, so we're gonna put the money into the system, each put our $10,000 into the system, into the blockchain, it's hard code in there, and then the system on a certain date will check 6 authoritative sources of rugby scores, make sure they're all lined up, and if they're all lined up, then pay the money across. So no trusted third party involved, it just happens, and that's the concept behind a smart contract. So Bitcoin was the first implementation of the blockchain, turned up about 7 or 8 years ago. It's been running 8 years. There are tens of thousands of computers, nodes on that network, and you can become a node on that network and run the software, be involved. It's got about $11.5 billion worth of US dollars worth of money in it currently, and so that's a pretty big target for hackers, but it's never been hacked. There's no way that it hasn't been broken. It's been running 8 years now. And there are numerous other blockchains now available. Probably the second most famous one is Ethereum, which turned up about a year ago. And this was a ground-up new blockchain, but not designed as a currency, but more as a platform to build smart contracts on. And for us, that was a really exciting point in this evolution because it allows so many other things to be done with the blockchain technologies. Okay, so the health sector. What's this all got to do with the health sector? I think the obvious use case, but this is kind of the big, hairy, audacious one, is about health records. So currently, DHBs, our GPs, our private DNA analysis companies in the States that we're all using, our insurance companies, our Fitbits are all recording information, health information, our health information. And these are all being stored in silos, in places that we don't control, these are the intermediaries that we're controlling our health information. It gets even more complicated when we're traveling and we're in different countries and we've got to deal with foreign systems who aren't talking to our systems where we live. It's siloed, it's insecure, it's replicated, and it's hard to access. Wouldn't it be great if we had control of our own health data? Wouldn't it be great if there was one authoritative source of data under our control that we could give whoever we wanted to give access to? Imagine a future where I could walk into my GP's practice in Sydney and give that using my digital signature, which is linked to my thumbprint on my iPhone, I could give that GP access to a subset of my health records, and then I could revoke it at a time that I choose. So that's the big goal that we believe blockchain technology can enable. And I'm not going to begin to say that it's easy. It's a big, complex picture, and I'm not an expert in those health systems. But we do know there's a bunch of projects going on around the world to actually do this. So we know it's happening, and I do believe it is the future. So that's the big, hairy, audacious goal. But there are a bunch of other interesting use cases. I'll just whiz through a few that's available. So medication provenance. So one of the big obvious use cases for blockchain technology is provenance, the chronology of ownership, being able to prove that something went through these series of owners and are real. And in a global marketplace where this concept is becoming increasingly important, and especially if this thing is a drug that could kill somebody, you kind of want to know it's real. So that's one obvious use case of the blockchain. Prescriptions, so the other one is blood donation. So imagine if we had a blockchain-based system that could track blood donations and their usage. If the system was crossed international borders, it created incentives for donors to donate a particular blood type at a particular time, at a particular location. Imagine there's a token that could be perhaps exchanged for flybys or local reward points for supporters of the New Zealand Blood Service. Wouldn't that be cool? So that's the sort of thing that we believe blockchain technology can enable. Another idea is some sort of health coin. So a doctor informs a patient they need exercise, patient agrees, there's some sort of token issued, and the individual performs that action, and it's tracked by a wearable, completes it, and it goes back into the shared ledger and becomes a sort of a trusted system for managing that and providing the right incentives to tackle the obesity problem. So that is 4 minutes early. God. So that is the 15-minute summary of the blockchain. If anybody wants a longer version, so I've given various presentations. They're up on our YouTube channel, 3 Months Limited. Sort of slightly longer one that goes into more detail. But yeah, lots going on. If you Google blockchain health records or health, there's some fascinating stuff going on in Estonia and various other countries, and there are a bunch of blockchain-based projects going on all over the place. Thank you.